So for those who couldn't join today's Zoom session, so I kind of thought of making this short video to upload so you all can kind of get a sense on how to do the assignment 7. So what basically you have to do in assignment 7 is there are compounds unknown A, B, C, and we are given you the mass spectrum of these unknowns, and based on the given information you have to determine the formula of this structure and then draw the structures based on the fragments. So the first thing when you see a mass spectrum, what you have to recognize is the molecular ion peak. So what is the molecular ion peak? It is the highest mass to charge peak. So where do we find that? So we have the highest mass to charge ratio if you see the x-axis. So all the highest ones are to the right side. Then at the right we see here there are 3 peaks. But here the definition says highest M to Z peak having the highest relative abundance. So based on that, the highest relative abundance is for the peak at 60. So we called the molecular ion peak, denoted as capital M, as the 60. So first thing is identifying the molecular ion peak. So once you have this molecular ion peak, all the other things to the left, all the other peaks we called as fragment peaks, and then you have to identify the next important thing called base peak. So the base peak is the most abundant peak, which is 43 because it has an abundance of 100%, right? So that is the most stable fragment or the most probable fragment that is likely to happen. And then next what we have to recognize is what is the M plus 1 peak. So once you recognize the capital M as 60, so M plus 1 should be this 61. What does it mean? It means it is for the isotopes. So most probably it is for the carbon C13 isotope. And then why does this have a M plus 2 peak? And if so, what does it indicate? So M plus 2, if the M is 60, so M plus 2 is at 62. So some people can be confused that because there is a small, very tiny peak at 62. So if there is a M plus 2, that means it is a halogen presence. That indicates there is a halogen presence. So halogens, we know those are chlorine or bromine. So next what you have to see is, if you are thinking this 62, this tiny peak is M plus 2, if you suspect, then you have to look at the ratio of these peaks height between M to M plus 2. So that means peak at 60, the height of the peak at 60 and the peak at 62, the height of the peak at 62. Whether is it 1 to 1, whether the heights are kind of similar, or whether at least it is 3 to 1. Does that work for any? So it is clear that it is not going to be 1 to 1 or 3 to 1, which is if it is 1 to 1, it is an indication it is a bromine. If it is a 3 to 1, it is an indication for a chlorine. But it's according to the data, it is none of them. So we say, okay, then there is no M plus 2 peak. The 62 may be a isotope of another element, maybe a hydrogen or oxygen, something. So that's what the things we get from looking at this mass spectra. So based on that, now what are the elements that are going to be in the molecule? So definitely it should be carbon, hydrogens, and then oxygens. Can we have nitrogens? No, because at this level in your guide and in your assignment you have clearly stated that for the simplicity disregard nitrogens. And now we know that there is no chlorines or bromines. How? Because there is no M plus 2, a significant M plus 2 peak. So then we have only these 3 elements. Now we have to determine the molecular formula. So I just put as CX because we don't know what are the values for the X, Y and Z. How many carbons, how many hydrogens and how many oxygens. So what we do is we are going to systematically starting with the largest possible number of carbons. So what I'm going to do is, so we know the peak, the molecular ion peak should be 60, right? So I would think then what is the maximum number of carbon atoms that it could have? So obviously only C5, right? Because if it is C6, it is going to exceed 60, the molecular ion peak, right? Because 60 is the molecular weight of the molecule, right? So if we have C5, it is 12 times 5, 1 carbon is 12. So if 5 carbons, it is exactly 60. But next problem is, can we draw a structure with just 5 carbon atoms? Will that satisfy all the bonding patterns? If I just draw this, does it satisfy any of the carbon's bonding pattern? What is the number of bonds a carbon should have? It should have 4. So this carbon only has 1. These carbons have 2 bonds around it, so it is not a probable structure. So some can draw something like this, but still in this case the terminal carbons, this doesn't satisfy the bonding patterns, right? It only have 1 bond. So then this C5 is not a probable structure. So that's how you would eliminate that formula. So then we know, okay, C5 is not working. Then we are thinking, what is next? So the next probable next carbon number is, we take, okay, maybe C4. So if we take C4, it is only 12 times 4, 48. So we need to go up to 60. So that means you need 12 more. So we can we put an oxygen? No, because oxygen is 16. If you put an oxygen, so it's going to exceed 60. So then what happens? So I'm going to put C4H12. Now, can this be a probable structure? So you have to draw and see. So I would first start with putting the carbons like this, and then if I put hydrogens at the ends like this, how many hydrogens I can put? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is only I can put C4H10. So 12 means it is exceeding the maximum number of hydrogens. So how you can find what is the maximum number of hydrogens you can add is, so you have, if you have Cn, so the maximum number of hydrogen should be 2n plus 2. For an example, so we took the C4, right? So maximum number can be C4H10, because 2 times 4, 8, 8 plus 2, 10. So that's how you would identify whether you have the maximum number of hydrogens, whether you are exceeding the number of hydrogens. So then we know, okay, C5 or C, whatever the molecule things we drew is incorrect, right? So this slide I took from our lecture, right? So you have to have an idea of about the common bonding patterns when you draw the structure. So for the carbons, you see, around carbon we have 4 bonds. So each time you have a carbon, you may have 4 bonds. And around oxygen, you have 2 bonds always. So the common bonding pattern for oxygen is 2. For nitrogen, you have 3. Likewise. And then what's the thing? Now we know, okay, C5, C4 not works. So then our next thing is C3. So when we think of C3, so these are the 2 options that we can come up with. So there can be C3 and H8O, or the next possibility is C2H4O2. So once we have that, now we have to start thinking of drawing the structures. So if you have a C3, first I would start drawing the 3 carbons in a stretch, so likewise, and then I could put the oxygen at the end, and now I would put the hydrogens such that it's gonna fulfill the bonding requirement of the carbons and the oxygens. So this could be the option 1 possible structure for option 1. And if we want to draw the option 2, so I would put the 2 carbons like this, and then since there are 2 oxygens, so I would first think of how I can put. So this carbon is already, the second carbon is already completing its bonding pattern, so the rest of the hydrogen should go here. So this is for the option 2. So like this, likewise, you have to do trial and error to figure out which is the most probable options. And then we have workaround on this problem. So here are some of the most probable options. Now next problem is how you're going to identify which structure is the correct one. So one thing we have to keep in mind is, using mass spectrometry we cannot definitely say which structure is the correct one. We need more extra data. So we always can say proposed structure or most probable structures. So you're not going to say exactly this is the structure, right? So now what I would go back to the mass spectra, and I would now choose some of the fragments. So for this assignment, I'm not expecting you all to give me all the structures for all the fragments present in the spectrum, but at least you have to pick up the most abundant fragments. So for an example, if this is the problem that I have given, I would expect that you are to pick the peak at 43 because it is the base peak, then at 45 because that's the next highest one, 42, 29, and 50, because those are the most abundant peaks that I see from this spectrum. Then I would try to figure out what is the fragments or which structure can give these fragments, right? So here I would at the corner I would write down what are the fragments, so I know what I'm looking for. So I'm looking for 45, 43, 42, 29, and a 50. So by this time you should know what fragment gives rise to a peak at 15. So definitely it is due to a CH3, right? So now which structure doesn't have a CH3? So it is clear that the option 2C doesn't have a CH3. So in that way we can get rid of this option 2. Next, now we have to figure out, so all the other structures gives 15, so we have the structure. Now we know that there's a base peak at 43, so that is the most stable or most probable fragment. So the structure that you choose should give rise to 43. So next, let's see the option 1B. So if I divide it here, so if I break the bond here, so I get two fragments, the left side and the right side. So the left side is for 15 and the right side is for 45. So that means I found two fragments that I am interested. And if I break it over from here, what happens? So I have a fragment here which is for 29, and then over here it is for 31. But I cannot, from the option 1A, I cannot make a fragment at 43. So that indicates this is not the correct structure. Likewise, you have to now work around drawing and figuring out what are the most probable fragments that each of these structure can give, and based on that you have to justify your answer and give me the correct structure. So these are the some of the workarounds. So this way of showing you what it shows is, so here they are showing with this straight line, vertical line, you break the bond at here. So there are two fragments going to happen. So the blue color, it shows the fragment to the left, so CH3 is 15, and the rest of the molecule going to give you a 45. So two fragments. Likewise, so if we look at the B, so here there is most of the fragments that we are interested. We have the 45 fragment, 43, 29, 15, but not the 42. So likewise, you have to kind of go through all the structures and figure out. So I hope this is going to help you kind of at least to complete the assignment 7. So good luck.